Hello, good evening. Welcome to today's problem solving session for the course Availability and Management of Groundwater Resources. My name is Shruti, and I'll be dealing with the problem solving sessions for this semester's course. I can see two of you have joined, Vishal and Gokula. Good evening, both of you.
Good evening, ma'am.
Ma'am.
We'll wait for a couple of more minutes to see if there are a few more people to join, and then we'll be starting the session. Okay, I think I'll start with the session. So before I go into the problem solving sessions, I'll be following a more of a questionnaire kind of a method where I'll be posting some questions on the PowerPoint slide, and I'll give you some minutes to read the questions and type in your answers in the chat box. Before that, am I audible and is the PowerPoint and video visible? Can one of you confirm?
Yes, ma'am, you are audible, ma'am.
Okay,
PowerPoint
thank you.
visible.
Thank you. Thank you. So this is the methodology that I'll be following, posting some questions. You'll be given some time to answer it. And preferably, if you can put in your answers in the chat box, I mean, it's okay if you can show it to the entire class or directly message me through the Zoom chat. I'll give some time for that, and after that we'll discuss what is the solution, and if there's an explanation related to that, I'll be also giving you an explanation of the question. So in this way, we can actually monitor whatever has happened in the lecture for that week uh, in the form of questions rather than just going theoretically blankly into the theoretical system. You can post your questions in. I mean, if you have any doubt regarding the sessions, after 1 hour, I'll be giving a break of 5 minutes. You can ask me doubts during that time, or you can also stop me in between and ask me doubts regarding the questions. Or there is also a forum where you can post your doubts and get it cleared from all of the experts. So feel free to interrupt me when you have any questions or doubts regarding anything that is being discussed during the session. And okay, so I hope I'm clear about how this will go about. So let's start today's session. Today's session it will be based on the lectures that were lectures 1 to 5 that was taken during the first week of the lecture series. And hi, Puru, welcome to the session. So this week's lecture will be taken based on lecture 1 to 5, and there has been an assignment posted in this first week as well as second week, which is supposed to be submitted by 7th August. So the week 1 and week 2 problem solving sessions will be helping you to deal with the assignment problems that is given in the portal. So if you are able to uh, practice this, I think it will be more than enough for you to. Uh, I think it is considerably um, covering the portions as well as giving you a practice to attend these questions that in future will also be required for your exam. So for those who have just joined late, what I'll be doing is I'll be putting some problems in the PowerPoint slide. We'll give you some time to read it and post the answers, and then I'll give you the solution and explanation of that. So we'll be starting with the problems. So the first question is, what is the continuous cycle of evapotranspiration, condensation and precipitation known as? There are four options: runoff, Earth's water budget, the water cycle, and the hydrogen cycle. Please post in your answers in the chat box, preferably direct message me so that you can not you can give your own answers, and then I'll give an explanation for the solution. Okay, thank you, Gokula. Gokula is giving me an answer. I mean, you can directly message. It's just Shalini has also given me an answer. Vishal and Puru, you can also try. Okay, I think I'll move on to the solution part of it. So Gokula and Shalini has given C. Puru has told D. So let's move on to the solution now. So the correct answer is option C, the water cycle. So let's know briefly about what are all these terms: the continuous cycle, what is evapotranspiration, condensation, precipitation, what is this water cycle, and everything. So this availability and management of groundwater resources is a subject or a course that is dealing with majorly dealing with a component of the hydrological cycle called groundwater. Now, what is this hydrological cycle? Hydrological cycle is nothing but the continuous circulation of water through the various spheres of the biosphere. Like water is coming down as rain, and then this water is going into is falling on the ground. It is going to flow from the surface of the ground into oceans, into rivers. Some of the water is going to seep down to the surface. Some water is going to further go down from the surface deeper into the deeper layers of the soil. So all of these process that is ultimately leading to this water that is coming down as rain, then traveling to the ocean, and then from the ocean it is again going to evaporate into water vapor and again become clouds. This clouds is again going to be transported, and due to various physical phenomena, it is going to come back as rain. So this entire cycle of water, the circulation and movement of water, the study of this is called hydrology, and the cycle is called the hydrological cycle. So hydrology is a word that means water. So study of the occurrence and the movement of water above the surface of the earth as well as below the surface of the earth is called hydrology. And this cycle of water movement, continuous movement of water is called hydrological cycle. Now, hydrological cycle is also in very commonly we use it as the water cycle. We also use the word water cycle as well. And this hydrological cycle, if you look into this components, precipitation is something where the uh, rain is occurring from the clouds, and it is something, it's an atmospheric component, that is the clouds in the atmosphere is condensing and coming down as rain onto the soil, onto the surface, and then from the surface it is again going into the soil. So this hydrological cycle, for the ease of understanding and ease of estimations, and uh, to learn it, hydrological cycle is divided into two categories. One is the hydrological cycle that is occurring in the atmospheric phase, and one is the hydrological cycle that is occurring in the terrestrial phase. So atmospheric phase is all of that cycle components that is occurring in the atmosphere, and terrestrial phase is all of those water movement that is occurring in the Earth's surface and below the surface. So let's get a more clear picture into the phases of hydrological cycle. Um, a few more of you have joined. I have started the session, and I'm already done with one question. So just to brief you about how this is going to go about, I'm posting some questions and you'll have to put in the answers in the chat box. Preferably direct message me and I'll be giving the explanation. So right now what is happening is the explanation of the first question. So going back, a hydrological cycle, like I said, is divided into two phases, the atmospheric phase and the terrestrial phase. Now you see the atmospheric phase has two components. One is the components like precipitation, that is liquid and solid phase of water coming down onto the earth's surface. Like rain is precipitation, the hailstorms are precipitation, snow is precipitation, rain is a liquid form of precipitation, whereas the snow and snowflakes and crystals and sleet and all of that are, sorry, not sleet, uh, oh, sorry, what is that word? Okay, sorry. It's not the correct word. The snow is what is the solid phase of precipitation, and rain is the liquid form of precipitation. Now, rain also is classified based on its different sizes. When it is a big droplet, it is called rain. When it is very tiny droplets, it's called a drizzle. So all those forms where the water is in the liquid form and coming down to the earth surface is called a liquid precipitation, and remaining snow and everything are solid precipitation. Now, again, the water in its vapor form is also moving in this hydrological cycle in the form of water vapor. So, the process of evaporation, where water is changing its phase from liquid to gas and going back into the atmosphere, is all including an interaction of the water within the atmosphere, from the surface to the atmosphere, from the atmosphere onto the surface. So this is basically comprising of the components in the atmospheric phase. Now, hydrological cycle is not only that atmospheric phase. Once this rain or precipitation or snow, which melts, reaches the Earth's surface, it is going to flow from the top of the Earth's surface. Some water is going to seep, or it is going to enter into the soil. Some water is going to travel further into deeper layers of the soil. So all of these things, all of these hydrological components that are involved, where the earth, surface or the subsurface is involved. The water movements in all of these surface and subsurfaces of Earth is included in the terrestrial phase. So some form of hydrological components that is involved in the surface part of the terrestrial phase is runoff, water that is flowing off from the surface as soon as the precipitation hits the surface. Then there is stream flow, that is water that is flowing through rivers, through streams and everything, through channels and everything. All of these come under stream flow. Now, when it comes to the subsurface flow, there are water movements where the water is seeping down into from the surface of the soil onto just below the subsurface of the soil. Some water that goes deeper into the soil is called, the process is called percolation. And then there is water storage. All this water that is going down into the layers of the soil are going to be stored as groundwater. So this is basically the classification of what hydrological cycle is. So from this, there are a variety of questions that can come. What form of what under which phase does the precipitation component of the hydrological cycle come? It will be under the atmospheric phase. And what is the component of hydrological cycle that comes under the subsurface terrestrial phase? And some examples are infiltration, percolation, groundwater, etc. So this is one whole idea about what the hydrological cycle is. So that was the first question. Moving on to the second question. If the rate of rainfall is greater than the rate of infiltration, then the excess water accumulating on the surface is it called a surface runoff, surface depression, surface detention, or surface discharge? You may put in your answers in the chat box. You can directly message me so that your answers don't influence the others, or you can, say anything. You can just put in your answers in the chat box. Okay, Purva, Uma, Gokula all have given me answers. All of you do participate because answering or doing these questions would really be helpful for you. I mean, you might not need further practice of these portions. Okay, Shalini's also given me an answer. Everyone do try. Okay, so moving on to the answer. Okay, let's move on to the answer. So the correct answer is surface runoff, like many of you have said. So let's see. It's the rate of rainfall, the rate with which the rainfall is hitting the surface. If it is greater than the rate with which water is moving down the surface, then obviously that amount of amount of water that is actually accumulating will increase, because all of this water that is coming down as rain is not able to seep into the earth surface or the soil surface. So as a result of which some water will start accumulating, and this water, instead of accumulating, it will accumulate and it will start flowing off from the surface, and this process is what is called as surface runoff. Now, what about surface depression, detention, and discharge? What are all these? What are the meanings of all these terms? Let's take a look into what all of this. Surface runoff is nothing but when excess water that accumulates on the surface, when the rate of rainfall is greater than the rate of infiltration, and starts uh, over the surface, and from the and there are different kinds of runoff. We'll be going later on into it, but basically, when all this excess rainfall that is flowing down the surface, flowing over the surface of the land, is called as surface runoff. Now let's go a little more deeper into the terms that are given in the solution. One of the term is surface discharge. Now it can be confusing because surface discharge, the term discharge is also something that depicts the flow of water. So, surface discharge is nothing but it is comprising of not just surface runoff. It is basically consisting of everything, every kind of water flow that occurs through the occurs over the surface, like what irrigation water discharge, water flowing as a result of outpour from industries, wastewater discharge, storm water discharge. All of these are some kind of water movement that is occurring on the surface of the earth. So all of those uh, kinds of discharge uh, that is not just surface runoff, it's also coming under this surface discharge. So that is how surface runoff and surface discharge is different. Now, surface detention, just like how the detention term means, detention is storage. Now, we know that water before flowing down, it will be stored until a proper slope or the required condition for its flow occurs. So that temporary, very short-term storage of water on the surface is called surface detention. Now, we also have a term called uh, surface depression. Surface depression is nothing but, uh, small depression on the surface. Depression storage and surface detention is somewhat related. So, when water is temporarily stored on the surface of the earth as a result of small depression, it is called surface detention or depression storage. So that was our second question. Now moving on to the third question. Which of the following is a source of groundwater? You can type in your answers into the chat box. Which out of the following is a source of groundwater? There are lakes, streams, springs, and ponds. Out of this, which fall under the category of groundwater? Uh, Gokula, Shalini, Puru, Uma. Oh no, wait. Yeah, Gokula is given. Puru has given an answer. Uma has given an answer. Navdeep has. Shalini has. Great work, guys. Vishal has. Hanumata. Great, nice work. I'm really, I really appreciate the involvement that you guys are showing here. It's appreciated. Okay, so I think let's move on to the answer discussion. There's Boli Shetty. You can also type in your answers. Then there is pretty much that's it. Okay, so let's move on to the answer discussion. Now, all these are water bodies, lakes, streams, springs, ponds. So let's see under what categories all of these come. So, like a lot of you gave the correct answer is springs. So let's see what are the different types of water bodies and under what category they come. Now we know that the all the water bodies in the earth surface, below the earth surface, all of them can be classified into two types. One is the water bodies on the surface, and one is the water bodies or the water components under the surface. That is subsurface water. So the surface waters, like all of us know, there are lakes, there are ponds, there are rivers, there are streams, there are water that flows through canals, there are reservoir storage, the water that is withheld by dams. All of these are on the surface. So obviously, it is coming under the surface water category. So something that is not very familiar with us, although yes, everyone might be knowing them, but some terms which are not so commonly used as the surface water are the subsurface water bodies, like springs. It comes from the water flows from the underneath of the earth surface and comes out. The such a source of water is spring. Then there are infiltration galleries and wells. wells itself, there are dug wells, like the big open wells. There are tube wells, there are artesian wells. So there are different kinds of wells as well. So let's see some description or get an idea about what this infiltration gallery, what are these artesian wells, what are flowing artesian wells, what are yeah, springs, and we know how water that is coming from the base of the mountain. Sometimes when we go into some tourist spots and all, there will be small outlets of water from natural outlets of water coming from mountains and all. So these are called springs. Infiltration galleries are nothing but horizontal wells. They are constructed below the surface of the soil or below the earth's surface, particularly below the water table. Now, if you have a water table level, below the water table, there are horizontal structures or horizontal wells that are constructed, which get the lateral seepage of this water from the water table, and then they store it. And then they have networks or pipelines connected to retrieve this water. So such structures are called infiltration galleries. This is one Yeah, so this is one schematic of water infiltration. You can see the water table is here, and this structure is constructed below the water table. Now this water table is connecting directly to the river. So there will be some movement of water, and water is going to enter to the laterally into these galleries, and they'll have these filter-like materials to control the amount of sand and gravel or whatever obstructions that are entering, and get some good amount of clear water in here. And these through pipelines or some pipeline network, water is retrieved for required purposes. Now, at the same time, what are these dug wells? Dug wells are nothing but the open wells that we all are familiar with. Uh, our tube wells are wells where there are cylindrical tubes that are bored into the deeper aquifers, so that we can get water from the deep confined aquifer. Now, these are also called artesian wells, because artesian wells are wells that are going into confined aquifers. Probably in the next week or so, we'll start with what is aquifer and what are the different types of aquifer. But for now, it is those wells which are smaller in diameter, and they are drilled into the confined aquifer level. So some artesian wells also have a situation where, because of the water pressure inside this confined, now this is a confined aquifer. So inside this confined aquifer, as a result of the pressure of the water will start flowing out of it. So such cases are called this is, I think, an example of the flowing artesian well. So such a well is called a flowing artesian well. So all of these are some examples of the subsurface water bodies: springs, artesian wells, tube wells, bore wells, dug wells, which are taking the water. The water source is majorly groundwater. It is not the surface water. The water source for all of these structures are groundwater. So that is why called as groundwater sources or subsurface water body. So that was about the classification of various water bodies. Moving on to the next question. The process in which water is absorbed by soil of any area by the downward movement of water during a rainfall. What is this process called? So those who have joined late, I'm posting some questions. You can put in your answers in the chat box, and then I'll give you the explanation. The question right now is fourth question is, what is the process where water is absorbed by the soil as a result of downward movement of water during a rainfall? I have answers from Navdeep, Gokula, Uma. Come on, everyone can. You can directly message me, or you can put it in the chat box. Yes, thank you. Gokula, Uma, Puru, Shalini, all of them have given answers. we shall do. Okay. Okay, Shailina. Interesting name, Shailina. I think that's the first time I'm hearing a name like that. Nice name. Is that the way it is pronounced? Shailina? Or am I pronouncing it wrong? Okay, never mind. Okay, I think we'll move to the answers. So here we are talking about the component of the hydrological cycle where water is being absorbed by the soil as a result of downward movement uh, after a rain occurs. So what is this process called? This process is called infiltration. Now, I did see a couple of them putting in percolation. So, one major confusion with the process of infiltration and percolation always persists when it comes to this hydrological cycle. So, let's go into what each process that is given in the answer is. So infiltration process is the immediate process where as soon as the rain hits the soil or rain hits the earth surface, the soil as a result of the capacity of the this water as a result of the capacity of the soil is going to move down into the immediate subsurface of the soil. This process is called infiltration. So what is the difference between infiltration and percolation is that percolation is the process where this water that has undergone infiltration, it is reaching the subsurface of the soil. Now, from the subsurface, it is when it travels further deeper down into the surfaces of the earth, then that process is called percolation. So, infiltration is the process of downward movement of water from the surface of the earth into the subsurface of the earth, whereas percolation is the subsequent movement of the water that is there in the subsurface into deeper layers of the earth or the subsurface. So this is the difference between infiltration and percolation. This is a question that can always come where they ask, what is this process? And confuse you with the process of percolation. The deep movement of water into great depths of the subsurface is called infiltration or percolation. So have an idea about what infiltration is and idea about what percolation. Now, condensation is a process where water vapor, which is evaporated from the surface or from the ocean, or wherever, it is going to cool down and change its phase from the vapor phase to the liquid phase. That is what we see on the surfaces of the glass and everything. So, drops of water. So, this process of water vapor changing from a gaseous state to a liquid state is called condensation. Sublimation is the process where water is changing from a solid state directly to vapor. Now, in condensation, if the water is changing its phase from gaseous state to liquid state or gaseous state to liquid state. Sublimation is where the water, which is in the solid state, that is in the ice, is directly turning into vapor. It is related to evaporation. Evaporation is when liquid phase is turning into vapor phase. Sublimation is when solid, that is ice is changing directly into vapor. Then this process is called sublimation. So this is about all of these portions in um, the this question. So I hope everyone is got an idea about all these terms called infiltration, percolation, condensation, sublimation. Infiltration and percolation are components of the water cycle, whereas condensation and sublimation, they are not processes in the hydrological cycle. They are nothing but physical phenomena that result in the phase transfer of water. So moving on to the next question. What is occurring when precipitation is exceeding evapotranspiration and runoff in an area? What happens when this rain that is occurring If it is more than the water that is going off as evapotranspiration and runoff, what will happen? Does it result in dry soil? Does it result in, is that what irrigation is called? Does it result in moist soil and possible flooding or vegetation? I don't know why that choice is given, but yeah. Yes, Gokula, Vishal, Uma, Guru, yes, Hanumanta, Shalini has given an answer. Shalina has two. RF Navdeep, it would be nice if also you could involve in the interaction. Yashwantu, okay, there Navdeep is also given an answer. Yashwantu, great. Nice. So let's see what this question is about. So here they've asked what is occurring if the rainfall is going to exceed the water that is getting the water exceeds evapotranspiration or runoff. So as many of you had told, the soil is going to be more moist and flooding is going to occur. So what happens when precipitation occurs, and if the rate of precipitation is more than the rate of evapotranspiration? Evapotranspiration is nothing but evaporation and transpiration. Evaporation is the water vapor going back into the atmosphere. Transpiration is the water that is released by leaves in the form of a water vapor. So if more water is coming down as rain, and it is exceeding the water that is going away from the surface, as well as the water that is going into oceans and everywhere, what is going to happen is the soil is going to keep getting saturated with water, and this water will not flow off in such a way. I mean, surface runoff is a good component that is actually transporting the water from one location back into the oceans and rivers where evaporation can occur. But what happens if this runoff is not occurring at a very fast rate? Rain keeps falling, and this flow rate is lesser than the precipitation rate, and water levels are going to keep increasing, and this is going to result in flooding. So this is the answer for this question. It is a very generic question, nothing to do with us knowing about, and of course, got something to do with the what is evapotranspiration. Navdeep, evapotranspiration. So it is a combination. Like I said, it is a combination term used in hydrology when we consider evaporation as well as transpiration together. So certain times, if you consider a plant, and if you're considering the soil or the surface around it, the amount of water that is transpired. Transpiration is nothing but there'll be stomatas on leaves, and this stomata is the plants are always going to give off water vapor into the atmosphere as a result of for the growth of the plant. That is a process that is necessary. So when transpiration and evaporation combine together, that term is called evapotranspiration. Why this term came into being is during earlier times, not now. Earlier times, the amount to in order to calculate evaporation and transpiration separately used to be difficult, because transpiration, relatively, both of the levels of water that is evaporated and transpired used to be less. So when we need to estimate that this component of evaporation and transpiration separately, uh, sometimes the transpiration rate would be negligible. So in order to overcome that kind of a shortcoming, scientists or researchers combine these two processes together and call it evapotranspiration. Or although in today's research has we have gone further into estimating accurate levels of evaporation and transpiration separately, so it is not required. But still, this is the practice that is used even now in all of the major studies, evapotranspiration. And we'll be going into that in probably, oh, I don't think in groundwater this is a relevant thing, but if it is in further sessions, it will be there. We can discuss it during this. But I hope I've made myself clear. And now let's go on to the second next question. What, sorry, in addition to personal use by people, large amounts of water are also used by what sector in the society? Yes. Okay, great. Vishal has given an answer. There is Hanumanta, Gokula, Shailana, Puru, Shalini. Great participation, guys. There, Navdeep has also given an answer. Arif too. Thank you for participating. Yashwan too. Okay, let's move to the answer. So here they asked us, apart from this personal use of water by people, a huge amount of water is also used in what sector, whether if it is in the agricultural and industrial sector, colleges to university, mining and manufacture, agricultural water parks. So the correct answer for this is agricultural and industry. Uh, if you see in colleges and universities, not, all of that come under the commercial use of water, which is not as much as we use in agricultural industry. Same in the mining and manufacturing. Again, this option, although it is giving agriculture, there's no much water used in water parks. So that is why this answer is not valid, although answer A is valid. So in particularly in India, which is an agricultural country, as a country that has a huge sector of agriculture, a large amount of water, apart from domestic and commercial use, is used up by agriculture as well as industries. Okay, so that was this question. Moving on to the next question. What is this water budget equation and how can it be expressed? So the water budget equation can be expressed as in the following ways. Which out of this option is right? Whether it is the first option where change in mass storage is equal to the outflow minus inflow, or the storage plus outflow is equal to inflow, or is it storage minus outflow which is equal to inflow, or is it storage equal to a ratio of the inflow by outflow? Which out of this is the right answer? Okay, there's a lot of answers coming in by Gokula. There's Navdeep confused between A or D. There's Shalini giving A, Puru giving A, Hanumanta A, Yashwant B. A lot of variety of answers. Shal also is given A, Uma is given A.  。  . 。  . 。 . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Charlie, B. Okay. There's a lot, I mean, except for the option C, I think all of the options have come in the answer. So let's see, find out what is the correct answer for this question and how we can, how, what exactly is this water budget equation. So the correct answer in this question is option B. Let's, uh, oh, okay. So the water budget equation, I had an explanation here, but unfortunately the slide is not there. But I'll just write it down here. So water budget equation is nothing but we talked about this water cycle. This water cycle is something where there's continuous water that is going in the this one. Water is it is not being lost, neither a new amount of water that is being this coming into the cycle. So whatever water that is coming onto the surface is going back into the atmosphere. So this water budget equation is balancing that mass of water that is coming in and going out. So the water budget equation is given in this way. Uh, okay, yeah. It is as delta S is equal to inflow minus outflow. So this is the water budget equation. So whatever water that is coming in, what are some of the sources of water that is coming in? What are some components where water is reaching the earth? Precipitation is there, that is rain is there, snowfall is there. All of these are inflow components. Now all of the inflow component is going to go back into the atmosphere. How runoff will take the water onto the into the ocean. Then evaporation will occur, which is again going to transport back. Otherwise there's a process where infiltration is occurring. Water that is infiltrated will go from the subsurface and it will go back into the rivers and then back into the atmosphere in the form of evaporation. So all of this water that is coming as inflow, it is also going back. So in case there is a difference between the inflow and outflow, that water is being stored at the earth's surface. Where are the storage points? There is groundwater. Then there is water that is stored in the river. Then water that is stored in the depression storages. All of this water is not going back into the atmosphere, but it is retained back. So if you consider there is 10 mm of rain, there will be 10 mm of evaporation. But suppose there is only 8 mm of evaporation, then we can say that 2 mm of water is remaining back in the earth's surface in the form of storage. So this is how the water budget equation is formed. That is change in storage. The difference between the mass inflow and the mass outflow of water is giving us the change in storage or the storage water that is stored in the earth, and this is called the water budget equation. So here there's none of the options that is giving inflow or outflow. Here it is outflow minus inflow, which is wrong. It is inflow minus outflow. But in this question, we have change in mass storage. So if you take change in mass storage and this component over here, it will become delta S plus O is equal to I. So this is how this answer is obtained. I just took this O component to the left hand side. So it becomes plus. So delta S plus O is equal to I, which is this answer. Here also change in mass storage minus outflow. That is wrong. It should be plus here. Change in mass storage is not the ratio of inflow and outflow. So I say this is the correct answer. So this is more like a trick question. It was, the equation for water budget is this. And they have just put the okay. We mass storage, we count both surface and groundwater or only groundwater? No, we also consider all kinds of storage. Now, water can come, soil water moisture. That is not groundwater. That is moisture that is retained in the just below parts of the soil. That is also considered as storage. Groundwater is also considered as storage. Any component that is not flowing out of the earth is considered as storage. I hope I made myself clear. Okay. So there are different storage components and different inflow components. So it's not just rain that is an inflow. Uh, even groundwater can come. Suppose there's a ocean and this groundwater is contributing into that ocean. Even that can be called as an inflow. So that is more deeper into hydrology. If you we can categorize groundwater flow as inflow, uh, subsurface base flow as inflow. All of these parts are coming under outflow, inflow, which is going more deeper into the hydrological aspect of it. But right now, in order to get an idea about what the water budget equation is, it is all of the water that is coming in is going out. If there's any difference, that is because it is being stored in the earth in the form of soil moisture or groundwater or surface storage as in the form of depressions or anything. So this is the right answer for this question. Okay, now moving on to the next question. This is a numerical. uh, Please take your time to read this, understand, and answer it. Uh, we have time, so we can think about it. Take a pen and paper, solve it. It is although it might look big, it is a basic arithmetical question. So a river has a wave that is passing through it. At a given instant, at a given point, the water volume or the storage of water is 17.5 hectare meter. After 3 years, the question asks is what will be the storage after 3 hours if the inflow of water is 6.2 meter cube per second and outflow of water is 12.6 meter cube per second. A problem which is similar to this has been taken in the has been discussed during the lecture session. So just think about it. What is storage here? What is inflow here? What is outflow here? It is all based on the water budget equation only. It only requires you converting the given quantities here into subsequent into required components and then finding the answer. Please take a minute or two to do this numerical and provide an answer. I think on that note, let's take a 5 minutes break. 2 to 3 minutes break. You can take your time, put in this answer. I'll give you 5 minutes and I'll be resuming the session in like less 5 minutes or less than 5. Okay, welcome back. Great work, Gokula. Um, Correct answer. Has anyone else tried the problem? Please put in the chat box if you need more time. We can wait for some more time and then discuss the solution. If you need more time, just show a thumbs up or um, some reaction or something. Should I discuss the answer? You can switch on your mic and answer. I mean, if you want me to go ahead with the discussion or you want some more time to do the problems, any of it, please let me know. I think we'll go ahead because I'm not getting any responses. B or C, ma'am. Okay, great. Thank you, Navdeep. Discussion, Navdeep is C. Great, great. Okay, let's go ahead with the answer. Okay, let's see how this problem is solved. Anyways, great, Navdeep and Shalini, I guess you guys have figured out the answer. Let's go into discussion of this. Like few of you told, it is 213880 meter cube. Correct answer is C. Let's go into the solution part. So here the question is, okay, now Yashwant also C. Great, great work, Yashwant. So let's see how this is done. So here they had given that the initial storage at some point in the at some river reach when it is passing at a given instant, the storage of water in the reach was estimated as 17.5 hectometer. So initially, the storage given is 17.5. What they have asked is the storage after 3 hours, and the other two given quantity is the inflow rate. It is not the volume, but the inflow rate. Whereas here they have given the volume, but here they've given inflow rate and the outflow rate in the 3 hour period. So what we have to do here is we have the initial storage as 17.5 hectometer. We will first convert it into meter cube because that is what all the rate units are given. So converting this hectometer into meter cube, you will multiply it with 10 to the power 4 because 1 meter cube is, 1 meter square, 1 meter square, 1 hectare is equal to 10 to the power 4 meter square. So you'll convert that into meter cube. Now we have got the storage volume 17.5 into 10 to the power 4 meter cube. Now what is given is the inflow rate. It is not the inflow volume, inflow rate. In order to standardize these two, what we do is we multiply this term with the time so that we can get the inflow volume. And the time given is 3 hours. So here inflow volume will be this 16.2 into 3 hours. So the unit, since it is here, since it is seconds in here, what we do is we multiply it with 3 into 60 into 60 seconds, and we get the total inflow volume that is happening in the beginning of in the during the 3 hour period is this one. So we got the initial storage volume, initial inflow volume. Same in the same manner, outflow rate is given. We calculate the outflow volume for 3 hours by multiplying it with 3 into 3600 and get the outflow volume. What we are required to find is the final storage. Now, immediately we might go to the water budget equation and see that inflow minus outflow is equal to change in storage. But then here, how do we find the change in storage? Here only the initial storage is given. If we need to find the change in storage, we need to find the difference between the initial and the final storage. It is only then that you will uh, get what is the change in storage. So what we do is we we have to find this final storage. We use the initial storage to find the change in storage and use the water budget equation. These terms in the water budget equation: inflow minus outflow, which we have calculated here. The inflow volume, outflow volume will give us final storage minus the initial storage. And placing, I mean, regrouping the numbers into LHS and RHS, we get the final storage is this value, 213,880 meter cube. I'll be posting these PowerPoints and all the videos. So if it doesn't make sense, first go, you can go back to this slides and see how the solving is occurred. This one is pretty, it's a very simple one. It's only a matter of you having to go through the problem and store in this water budget equation and what these water budget equation means and how to obtain the quantities. So this is how this problem is done. Good work, all of those who gave the answer. Moving on, again, this is another simple numerical problem. In a reservoir, it is given that the seepage loss. Seepage loss is nothing but it's an outflow component. I can give you that clue. Is equal to 2.5 centimeter. Precipitation is 18.5 centimeter, which is an inflow component, and evaporation is a 9.5. Evaporation is 9.5 centimeter. So here the trick is basically they'll just give the components. You have to identify which is inflow and which is outflow. So seepage loss itself is indicating that water is going away. So it is an outflow component. Precipitation we know is an inflow component. Evaporation, water is going out. So again, that is an outflow component. So using the water budget equation, what will be the answer? One important thing that you need to see here is what units the quantities are given in the question and what units the answers are. Usually that is one major mistake a lot of us make. We will not give much thought into the units given in the question and in the solution and end up choosing the wrong answer. So please always uh, always take note of the units which are provided in the question. Even in the earlier problem also, this problem also. Okay, Uma has given an answer. Gokula 2. Shalini 2. Aris has also given an answer. We got B, C, A as answers. Let's see what is the correct answer. You, I mean, all of you please give it a shot and give me whatever answers you get. We shall do. So except for D, I guess I got all of the answers. A, B, C. Everyone has given. Few of you have given A, few of you B, few of you C. So and then figuring out it will be the units, that is the reason why the wrong answers are coming in. But yes, let's see how the solution. There we go. Simple water budget equation. Like I said, this is the inflow term and this is the outflow term. So we'll first add the outflow term, which is evaporation and seepage loss, which is coming to around 12, 5, 10, 9, 10, 12 centimeters, 12 centimeters. You have to take care that you convert it into meters because the answer is in meters. Similarly, precipitation is the inflow component, again in centimeters, converted to meters, and subtract the inflow minus the outflow to get this answer. So the correct answer is C, 0.065. Let's see. I think except for Gokula, everyone else got a different answer. You want to check why, where you went wrong? Just a second. Please hold on. I've got here, Uma, Arif, be pushed by mistake. Okay, that's okay. Uma is again saying that the centimeter to meter correction is not done. So this is one very common error that all of us make, including me. So I think we should be careful of that. Okay. Okay. Now let's move on to the next question. The highest, these are some very simple questions that are coming. The highest percentage of freshwater resources that exist are in the form of rivers and streams, lakes, ice caps, and glaciers or groundwater. Now, what you have to focus over here is the keyword freshwater. We have not asked the highest percentage of water exists in the form of. Here we are asking about the highest percentage of freshwater existing in the form of. Okay. Gokul has given me an answer. Yeah. Arif 2, Hanumanta 2. Shalini, Uma, Guru. Yes, Navadip. Any more? Okay, this is a pretty simple explanation. Let's go to the explanation. So let's take a look into the segregation of water in the form which they are. So we are all aware that 97% of water, the total water that is existing in the earth, 97% is salt water, and it's only around 3% which comes as fresh water. So even in salt water, water that you found in the oceans is 96.5%. 0.9% is other saline sources like maybe salt lakes or anything. And fresh waters are only 2.5 percentage of the entire water in we have. Only 2.5 percentage of water is available as fresh water, and that is that amount of water that we are exploiting or we are using and exploiting it. In that 2.5 percentage, majority of that 2.5 percentage is contributed by glaciers and ice caps. In contrast to our belief that We have a lot of surface water. Glaciers and ice caps is what is contributing to around 68.7 percentage of the freshwater resources that we have. Then after that comes groundwater on a 30.1 percentage, and the remaining surface waters like lakes, rivers, ponds, soil atmosphere, all of those surface waters is from where we usually get water is coming under only 1.2 percentage of the entire freshwater uh, resources that we have. So unlike, I mean, although we are using a lot of water from surface waters, it is only contributing a mere 1.2 percentage of the freshwater resources, while a major portion is contributed by glaciers and ice caps, and secondary to that, it is groundwater. And you can see here there's a classification of the surface water also. Uh, Living things comprise of 0.26%, rivers are only contributing 0.49 percentage of it. Most is contributed by lakes, and the greatest amount again there by permafrost and ground ice. So that is the segregation of the resources of water at a global level for fresh water and the surface water. So this question was highest percentage of freshwater resources exist in the form of ice caps and glaciers. Second, it is groundwater. Surface water sources like lakes, rivers, and streams are coming as the third classification of total freshwater resources. So that is a very interesting question. Moving on, next one, some statistics that you have no other go but by heart. Um, the Indian state with the highest groundwater resources is it Kerala, Punjab, Karnataka, or Uttar Pradesh. I think unless you go to the lectures and videos which has this information, it's difficult. You just have to just know. Yeah, everyone is giving a shot at whatever they feel is right, which is okay. Yeah. One Kokila is saying it's Uttar Pradesh, Uma Karnataka, Vishal is saying it's Uttar Pradesh, Guru also Uttar Pradesh, Hanumanta also Uttar Pradesh, Selina is saying it is Kerala. Vishal is also saying it's Uttar Pradesh, Uma Karnataka, Navdeep. Okay, one more Karnataka. So one Kerala, lots of Uttar Pradesh, and two Karnataka. So let's see who has got the right answer. So if you see this statistics, there's one more which contributed to D. Okay, again Uttar Pradesh. So according to this resource, the source over here, I'm sorry, let me just. So you see here, there is in this list is
Ma'am, your mic has been muted.
okay. Sorry for that. Yeah. So we see here in this list total annual replenishable groundwater resources in billion cubic meters. Andhra Pradesh is showing 35.89 in this list. Here is Maharashtra, Madhya Pradesh, Karnataka has only 17.03 billion cubic meters, and Kerala 6.69, very less groundwater. Karnataka has got 17.03, and we had one more place. Which place was that? Punjab. Punjab is not here. Is Punjab here? No, Punjab is not here. So let's see how much water is there in Punjab. Has 22.53, while Uttar Pradesh has the highest amount at the 77.19. billion cubic meters of groundwater. So most of you had given that answer, which is the right answer. Uttar Pradesh has got the highest amount of groundwater. I am not. This data has been taken from this publication, which might be a little old. Although I don't think so, there will be a huge difference in the values in the latest publications as well. Correct answer in this case is Uttar Pradesh with 77.19 billion cubic meters. So again, that was an interesting question. Moving on, this is again a repetition of what we had discussed earlier. Dash of the total water in the world constitu- constitutes fresh water. What percentage of water in the world constitutes fresh water? I'm pretty sure all of you will be able to answer this. So I am surprised. We just went through this total water. What percentage is fresh water? Right. I think you all of you had. I don't know where you went wrong, but yeah, maybe you might have thought it was surface water. Anyways, yes, all of you, almost all of you corrected whatever you said. Let's go into this. We had discussed this earlier. I don't know if it's there. This one we had talked about uh, total global water, 96.5 oceans, 0.95 other saline, and 2.5 percentage fresh water. So here the option given is less than 3 percentage. So the correct answer is option B. Moving on to the next question. Which of the following options is the most conventional source of municipal water supply? For all of us getting water from the municipal water supply, which is the main source of water for this municipal water supply is the question. So we have Gokula, Uma, Tushar, Dhruv, Deepika, Helena. Yeah, pretty obvious. We don't get our water from the houses from glacial ice caps. Neither is it recycled water that we get as water supply. Probably for gardening and all we get. Seawater again not an option. So the only option is river water. No, Arif, we don't get recycled water for as water supply into our houses. Probably they have that recycled water in apartments and all for gardening or any other purpose. But as of now, no. In India, they don't provide recycled water for municipal water supply. So the correct answer is river water, like most of you had said. The next question. A typical municipal water supply system in a city usually provides water for what all purposes? Is it domestic use, public facilities, the commercial centers, or all of the above? Pretty simple question. What is a municipal water supply system in a city? Usually provides water for domestic use, use in public facilities, commercial centers, or all of the above. These all of you have, a lot of you have answered. Again, this is based on what understanding of what a municipal water supply is. Municipal water supply is nothing but in when you live in a municipality or a corporation, water the waters that you get are directly not from river. It is coming through a network of pipeline that is connecting, that is taking water from a far away source and bringing us this water through a network pipeline network system into our houses. Now, in a municipality, we just don't have houses. We also have shops. We also have schools. We have colleges, institutes. We have parks. So, water, all of these places are getting water from the municipal water supply itself. So, the answer right in this question would be all of the above. We are getting municipal water supplies for domestic use as well, for use in public facilities like malls or shops or parks or wherever, commercial centers like I said, malls or shops. Then there are schools everywhere. Municipal water supply is providing water. So the correct answer is option D, like most of these. Moving on to the next question. The single largest consumer of fresh water in India is which sector? Is it the industrial sector, agricultural, power generation, or domestic sector? Right? Kokula, Shalini, Uma has given answers. Any more answers? Then Arif also says it B. Shalini also says it's D. Puru says it's D. Okay, let's move on to the answer. It is agriculture. In India, the largest consumer of fresh water, that is water from rivers and as well as groundwater. In some places, they even use bore water and all for agricultural purposes. Domestic, yes, but not as any. We also use water for domestic purposes, but more than that, agriculture sector is using most of the freshwater resources in India. Now, moving on to the next question. Which out of the following comes under the transportation components of the hydrological cycle? A hydrological cycle, we earlier learned two categorization of hydrological cycle. One is the atmospheric phase and the categorization, atmospheric phase and the terrestrial phase. This is based on the movement of the hydrological component, which moves and which doesn't move. So you can see, if you know what soil water is, what ponds are, what is transpiration, what is groundwater, we can know which comes under the components that move and which doesn't come, that doesn't move. So Shalini says it's transpiration, also transpiration. Shalina says it's groundwater. Come on, more of you. Why is the energy going down? Keep participating. Kokla says it's soil water. Uma says it's groundwater. Deepika says it's groundwater. Any more answers? Gokula says it's not uh, A but C. Okay. Okay, let's go on to the answer. So it's transpiration. So let's see why it's transpiration. So here they have said soil water that is there in the soil. Then ponds, transpiration, which is the process in which water leaves the leaves and reaches the atmosphere, groundwater. So it is basically the terms that is provided in the answer, which is making it a storage component or a transportation component. So now, components of hydrological cycle. Like there are a lot of things that contribute to the hydrological cycle: precipitation, infiltration, runoff, stream flow, evaporation, transpiration, um, depression storage. All of these are components of hydrological cycle, which comes under the transportation flow components, and which comes under the storage components is what you see here. So here, precipitation is the movement of water from the atmosphere onto the Earth's surface. Evaporation is the reverse one. In the form of water vapor, water is leaving the oceans or the surface of the Earth back into the atmosphere. Again, this is movement of water. Transpiration also, water is moving from the leaves to the atmosphere in the form of vapor. Infiltration is the downward movement of water into soil. Runoff is the lateral movement of water from one point on the surface to the oceans or another point. Whereas storage components of hydrological cycle are what is the storage is happening. There is ponds, there are lakes, there is well, depression storage, then water that is stored in soil, water that is stored as groundwater. All of these are coming as storage components. So this is what is basically categorizing the different components of hydrological cycle into transportation or storage components. So this is also a very interesting question that can come. If you say, suppose if they had given stream flow or river flow, then that would have been a transportation component instead of ponds. Again, in case of groundwater, if they said groundwater movement, then it would have been a transport component, because they are indicating movement of groundwater. So I hope you get an idea about what is the transportation component and storage component. Again, this is a question based on the water budget equation, except that instead of inflow and outflow, they have given the different components of the hydrological cycle. So it is up to us to identify which are the inflow components and which are the outflow components. And the explanation of the terms: P is precipitation, R runoff, G is groundwater flow, E is evaporation, T is transpiration, and delta S is change in storage. So we know water budget equation, which all components come under inflow category, which all outflow category. Based on that, what will be the answer? I'll see. Localized side, it is D. Come on, guys. Women. Everyone tired. Half an hour more and the session is done. Silent answer says is given an answer. D. Uma, Vishal, Puru. Some of the answers. I mean, says A. Okay, let's move on to the explanation for this. So here we see that the correct answer is C. Why? Because precipitation is an inflow component and all of the remaining are outflow components. Surface runoff is the movement of water from its starting point to an end point. Groundwater flow also, from wherever groundwater is stored, it is going away. Evaporation also, from wherever water is stored, it is going back to the atmosphere. Transpiration as well. So all these four components are outflow components. So if you put this as in this format, if you put it as all of these four components, if you put it like this, it is coming under outflow. Here it will be plus, 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 but then all of these are outflow components and this is the only inflow component. So that is why option C is the right answer for this question. So the Okay, let's move on to the next question. This is the explanation for it. R, G, E, and T are the outflow components. So P minus R minus G minus E minus T, or P minus inside bracket R plus C plus E plus T will be the change in storage. Now, which of the following does not come under rainwater harvesting? This is also one portion that has been covered in your lecture. What is rainwater harvesting? What is sustainable water use? So, which does not come under rainwater harvesting? Is it recycling wastewater, rooftop rainwater harvesting, recharge structures for wells and borewells, or micro catchment water harvesting? We have Hanumanta Puru giving us answers. Shalini 2, Gokula 2, R 2. No more answers. Okay. Okay. Shalina is saying A. Gokula is saying A. I think pretty much all of you have an idea about what all comes under rainwater harvesting. So let's move to the answers. So it's like a lot of you told, it is recycling wastewater. So let's see what comes under rainwater harvesting and what is under sustainable water utilization. So rainwater harvesting is nothing but you collecting rainwater and then using it after adequate treatment or without treatment for whatever purpose. So the most common way is rooftop rainwater harvesting. Whatever water that is collected on the roof, we are transporting into some storage facility using drains. That is one way of rainwater. Then revival of traditional water harvesting structures. Like if there are old wells and all, water is transported into these wells. Rainwater is transported using pipelines, and that is this revival of traditional water harvesting structure. Then micro catchment water harvesting. A portion of the land is prepared in such a way that it will collect the rainwater. Then recharge structures for wells and bores. Again, when the wells are again replenished with water, rainwater, that is also one way of rainwater harvesting. And contrary to that, sustainable water utilization is making optimal use of water such that we have our needs fulfilled as well as we keep sufficient quantity of water for the future also. So for that, we have to optimize the use of water. That is minimize. So a lot of water is wasted when we, particularly in bathrooms while brushing, we open up taps for a long time, even though it is not necessary required. In flush tanks there is a lot of water loss. So that kind of domestic water consumption, if it is minimized, it is called a sustainable water utilization. Similarly, recycling this wastewater and using it for various purposes is a sustainable method. Improving irrigation methods by using drip irrigation and sprinkler irrigation, it is actually saving a lot of water. So these techniques are all sustainable water use techniques. Okay, next question. What is the average annual per capita water availability in India? What will it be in the year 2031? So these are some values that you have to keep in mind, and the questions can come from your lecture series. There are a lot showing about giving statistics, so you might have to, you know, some memorize all these. Others and all, you can just understand the concepts and numericals also, but there are a couple of things that you'll have to keep in mind too. Okay, so we have Hanumanta, Gokula, okay, this is not an answer that, I wouldn't blame it even if you don't know it because it's all numbers. So it's not very easy to keep numbers in your head. Let's just see in which part of your lecture it comes. The correct answer is 1,367 cubic meters. I got this from an online source which says the average annual per capita water availability in the year 2001 was this much. 2011 it was 1,500 something, and then it further reduced in 2021 to 1,486. In 2031, apparently there will only be 1,367 billion cubic meters of water available per head in every year. This is the resource I got it from. If you can, when I share uh, the slides with you, you can go to this link and find out from which publication this has been taken in the lecture series. Okay, so that's the answer. Okay, so one common thing that you can see is the water has been reducing in 2031. Now we have already reached 2024. So that way you can remember 1,367 billion cubic meters of water will only be available in the future. Moving on, next question. What is the suggested benchmark for urban water supply in India according to the Ministry of Housing and Urban Affairs? Is it 55 liters per capita per day, 100 liters per capita per day, 180 liters per capita per day, and 135 liters per capita per day? The benchmark for urban water supply in India. Puri, Uma, Shailina. Okay, let's go to the answer. Deepika says A, Monish says D, Gokula says C. So the obvious confusion comes between 55 and 135 because we have both of these quantities as per capita water uh, per capita per day water quantities. Now let's see which is for which. So according to the Ministry of Housing and Water Urban Affairs, 55 liter per capita per day is provided in rural areas, in urban areas. That is why I kind of stress this term urban water supply. 135 liters per capita per day is assigned in urban areas, whereas 55 liters per capita per day is assigned for rural areas, mostly the domestic water supply. So probably that is why a lot of you gave A and B interchangeably. It is because even this quantity is there, but it is for rural areas. It is 135 for urban areas. Moving on to the next question, again a statistic, which is something not very easy to remember, but you can if you go through these slides. What percentage of water was used for irrigation out of the total water use? What percentage will be used in 2025 under a high demand scenario according to the NCIWRD report? Um, So here they're saying these are all simulated, forecast, predicted values. It's not something that we have already used, but based on what the usage has been in the previous several years, they are going to calculate how will be. We know that in the future coming years, there's going to be climate change. They'll be taking that. Along with that, the population is going to increase. So they'll predict what is the population at that time. They're going to consider what kind of usages we have now. So based on all of that, prediction for a very high demand scenario. High demand is when population is going to be a lot, but the supply is going to be less. What is going to be the water consumption used for irrigation? And this is given by the NCIWRD, and they say that around for 2000 they have given this water requirements for high demand scenarios for 2010, 25, and 50. The question here is for 25, and according to that irrigation amount of water that is going to be consumed for irrigation is around 72 percentage of water. So if you see, you can again this data you can get it from this link that I posted here. I don't think so it's there in the lecture series. So you can go into that and keep I mean store it with you because this question has indeed come during for the assignments. So although it is not there in the lecture, it has come, so you can keep this thing with you. So here they say 72 percentage will be used for irrigation. All in 2010, if 78 percentage was only used, 72 percentage will be used in 2025, and by 2050 it is going to reduce to 68 percentage. So the correct answer here it will be B, because around 72 percent, 72.48 percentage is the answer given. So it will be this one. The full form of NCIWRD is National Commission for Integrated Resources Development. You can always go check out, I mean, Google this commission's water report for high demand scenario and get the data from there, or you can access this link. Moving on to the next question, which ministry launched the Jal Shakti Abhiyan campaign for water conservation and water security? This is the Ministry of Jal Shakti, Ministry of Housing and Urban Affairs, Ministry of Environment and Forest, or Ministry of Agriculture and Farming. Pretty simple, right? Right. Vishal, right? Mukula, right? So let's move on. It is the Ministry of Jal Shakti. It is again the Ministry of Water is called as Ministry of Jal Shakti now. So, including the state government and the central government, they have formed the Department of Drinking Water and Sanitation under the Ministry of Jal Shakti, which is offered this Jal Shakti Abhiyan campaign to conserve water and to secure the usage of water and availability in the future. Next one, which government initiative aims to provide functional household tap connection to every rural household by 2024, which is basically now, since these lecture things were, you know, made earlier. By this year, the scheme should ensure that every house has got a tap connection to provide water, which initiative this I mean, aim was to do this. This is the first one, Atal Mission for Rejuvenation and Urban Transformation, Jal Jeevan Mission, NPP, or is it Har Ghar Jal? If you say it's B, if you say it's D, mm, B or D, yeah, right. I have they given both the options, Jal Jeevan Mission and Jal Jeevan Mission Har Ghar Jal. Okay, let's go check out the answer. So this is the description of whatever initiatives. The first initiative, which is Amrut, Atal Mission for Rejuvenation and Urban Transformation. This was launched in 2015, and it is taking care of all the basic infrastructures for certain towns and cities for in the sector of water supply. Not only just tap water, it is taking care of sewage water, treatment of sewage water, stormwater management, provision of water in parks, developing parks and spaces, non-motorized urban transport. And this is not coming under the Ministry of Jal Shakti, but it is coming under the Ministry of Housing and Urban Affairs. Now, Jal Jeevan Mission was the mission that introduced this giving tap connection to every household by 2024 that provides safe and adequate drinking water. The other option is National Perspective Plan, which is again Ministry of Irrigation in 1980, not in the near thing, where interbasin transfer of water would be done. Mm, Water which is available in plenty in certain river basins will be transferred to water deficit places, and this is not in recent years. It was a plan that was developed long ago, around in the 80s. Jal Jeevan Mission is what that provides household tap connection to water. So the correct answer is B. I know this option is also very confusing. Har Ghar Jal. I think both B or D would qualify for a correct answer. Now, Okay, this is another on the transportation component. Which component of the hydrological cycle involves water movement as water movement of gas and liquid solid in the atmosphere? Yeah, gas as well as liquid movement in atmosphere. Which component? Answer A, answer B. It says gas as well as liquid or solid. So it's A, Selena, B. Mhm. Let's go. The correct answer is not C, it is A. I'm sorry, this is an error over here. Correct answer is A. Transportation component. Component of the hydrological cycle that involves movement of water as gas. The question here is gas and solid, liquid and solid. So it will be transportation component, not uh, correct answer is not C. It will be A. I'll change this error in the slides and then post it, share it with you in the Google Sheet. But for now, you have to know that the correct answer is A and not C. Now, which of the following is an industrial water conservation measure? We know water conservation measures. In that, which water conservation measure out of these is an industrial measure? Is it sweeping the sidewalks instead of forcing them? Is it installing low volume shower heads, the shower in things in our houses, growing drought resistant crops, or is it reusing cooling water for irrigation? Pretty direct. It definitely is an F, Uma, but yeah, I think I get it here. Um, okay. D, D, C. Okay, so let's move on. It's the correct answer is D because industrial conservation is, I mean, this is nothing related to industry. The um, sweeping sidewalks instead of hosing is not a industrial water conservation measure. It is a general water conservation measure that we can do in public areas. Installing low volume shower head, it is a domestic water conservation technique. Growing drought resistant crop is a water conservation technique associated with the agriculture. In the sector of agriculture and irrigation, we can do this to conserve water. Using cooling water. Coolant is water that is generally used as a coolant for sudden cooling of heated parts or heated substances. It's called cooling water. So this cooling water can be reused because it is not getting contaminated or polluted in a very bad way. So we can use that cooling water and instead you reuse this water that has been cooled. Generally, they are thrown off. Instead of that, it can be used for irrigation. So that is one water conservation technique, industrial water conservation measure. Moving on, which of the following reservoirs contains the most uh, water? This is the atmosphere, biosphere, groundwater, lakes, and reservoirs. C, C, A, groundwater. Okay. Since we just have 5 minutes and a couple of more questions, I think I'll just rush through the questions. Um, So biosphere is nothing but comprising of atmosphere, lithosphere, hydrosphere. Hydrosphere means the water bodies, lithosphere is the earth, and atmosphere is the atmosphere, the air thing. So in this option, it is given if this atmosphere is not containing the most water. Biosphere is comprising of all three, this one. So it is not a very clear answer. Groundwater, on the other hand, comprises of the most water, as we had seen in the classification. I don't know if it is here, but we had seen that groundwater is what is comprising of 30% of the fresh water. So we can say it is groundwater. Lakes and rivers is only contributing a very few percentage of water, like I said in this. If they had given hydrosphere, yes, it would have made sense. But here they had given groundwater, which is actually contributing to a major portion of the water in the fresh water. So the correct answer is C, groundwater. Question 7. Which of the following statement is true? Cool air can hold more water vapor than warm air. The opposite. Both cool air and warm air can hold the same amount of water, or air cannot hold water vapor. This is, I think, small class physics question, science question. Okay, answer. Mark says is A. Okay, let's move on to the solution. So warm air is going to have the higher capacity to hold water. This is because in when the temperature increases, the bond between water molecules will separate and it will expand. So there will be more space for more water molecules to come. Whereas in cool temperature, the water particles are very much together. So there is no much space for extra water molecules to come and get inside. So warm air will reach its saturation point much later than cool air. So it is warm air can hold more water, and that is why generally during summer seasons and all we feel humid. Whereas in places where it is cold, there is no much sweating, or we don't have our skins become a little more drier than it is during summer, because this is the reason warm air can hold more water. So there will be more humidity during the summertime in contrast to very cold dry period. Next question, again something related to this. What is the term used to describe the process of water vapor turning into liquid water? Yeah, gaseous water into liquid water is called what? Is it called condensation, evaporation, transpiration, or precipitation? Okay, sorry, B, 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 A. I think a lot of you are getting, I mean, read the question properly. It is water vapor turning into liquid water, not liquid turning into vapor. Okay. So it's the correct answer is condensation. When water turns from vapor to liquid water, it is condensation. Evaporation is when water turns from liquid to vapor. Transpiration is also a process of water turning from liquid to vapor. Precipitation is rain, so it is not the correct answer. So correct answer is A, condensation. Be clear about what these processes are. It might take, I mean, you just have to revise or learn what is condensation, what is evaporation, what is sublimation, what is transpiration. There are a lot of Asian terms, so just be clear with all of these terminology. Next, most groundwater is withdrawn in India. Withdrawn in India is used in which sector? Is it in the industrial sector, irrigation, drinking water, swimming pool? You say it's irrigation. You want to say it's industry, irrigation. It said India in here. Yeah, India. In India, where is it used? The correct answer is irrigation. The most of the water in India, the major consumer is the agricultural sector. So, all most of you have said the correct answer is irrigation. Puru, Shailina, Arif, Deepika, all of you have given the right answer. It is irrigation. The last and final session for this um, final question for this session is water that is good enough to drink. What is it called? Is it called potable water, groundwater, surface water, or artesian water? Okay. Hanumanta says it's A. Puru says it's A. Come on, last question. Okay, I'm not torturing you by asking you all of you to put in your answer. It is right. A is the correct answer. Potable water is called drinking water. Water that is fit for drinking is called potable water. Um, so that marks the end of today's session. Our session is scheduled for 6 to 8, and since we don't have any extra time now, please feel free to drop in your doubts in the forum, or you can go through all of these questions and revise it. And if you have any doubt, you can ask in the next session or put it in the forum. Anyway, so thank you all for attending today's session. Yes, I'll be sharing the PDF as well as the video of this, and all of you participated really well for these 2 years, and I really appreciate that. I think it will be more interesting if we both can interact with each other and do these questions. Will be a great practice for you. So thank you all. Have a good night, and I'll be sharing this um, um, the PPT as well as the video link in the Google Sheet that has been shared with you. So thank you everyone. Good night. Have a great week.